Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And this short video, another video in our series dealing with functions, and more importantly concentrating on injective functions, and whether functions are injective or not, okay, is another example of, I suppose in this case, where we have a function that's not injective. But I suppose before we can actually get to the stage of actually testing whether a function is injective, we need some sort of definition, okay? So once again, let me just give the definition, and I've provided a definition for each one of the videos that we've considered, okay, up to this particular stage. So our definition is, well, if I want to test whether a function is injective, I need to have the function in the first place, okay? Which means that I must know where the function is mapping from and into. In other words, I need to know its domain and its codomain, okay? So we need that. So let A and B be non-empty sets, okay? And let F be a mapping, from A into B, if that makes sense, okay? Then we say that F is injective, okay? We say that F is injective, okay? If for all x1 and x2 that are in our domain, okay? For all x1 and x2 in our domain, okay, and so we say f is injective, okay, if for all values out of our domain, okay, we have the following, okay, and I'm going to provide two definitions, okay. So we have the following, okay, if x1 is not equal to x2, well then this implies that f of x1 is not equal to f of x2, okay? Which is basically saying that we have two separate values in our domain, and if we apply the mapping, well then they are mapped to two separate values in the range, if that makes sense, okay? Alternative definition that we could have, okay, an alternative definition is, okay, let's assume that we have two values that have been mapped to the same place in our range. So if f of x1 equals f of x2, okay, well then this implies that x1 must be equal to x2. So we end up with two definitions. We have two definitions of what it means to be injective. Okay, they're the same definition, but they're just taking different approaches to the actual consideration of the characteristic. Okay, so we have two definitions. Okay, the first definition says, okay, we have two values in our domain that aren't the same. Well then, if the function is injective, that when we map them two values across into the range, we must get two values that are different, okay? Alternatively, what it's saying is, well, if we have two values in our range that are the same, well then this implies that the two values in the domain where they came from, they must have been the same value. In other words, the only way we could get two values in the range that are the same is if the values had been mapped across from the same point, okay? So that's what we have. So let's consider a function. Yeah. So let's consider the function. Okay. The function. Okay. Let's say f, which takes the integers, is mapped into the. Let's say it's mapped into the rationals. If that makes sense. Actually, I probably should map the integers into the integers here. Okay. But it doesn't make any difference because the rationals contain the integers. Yeah. Okay. So the codomain is q, but actually the actual range is actually going to be z, if I'm not mistaken. Okay. So and it's defined by f of x. Okay, f of x is taken to x squared plus 1, okay, if that makes sense, okay. And the question is that we have is f injective, okay? Is f injective? That's our question mark. That's the question that we'd like to answer in this particular case, okay. So let's just keep in mind that the function that we have is defined here. Here's our function, okay. It's defined, we've provided the domain and the codomain, and we've provided the actual prototype or the implementation of the function, how it works. So what we're going to do is we're just going to take the second approach here, okay? Let's take this approach to tackling this problem, okay? So if we take this approach, we must have two values that came from a domain. So let's say let x1 and x2 be elements of z. In other words, they came from a domain and they were mapped into a codomain, okay? And also let f of x1 equal f of x2, okay? So the two values, okay, have been mapped to the same value. Well, what's the consequences of this? What does this imply? Well, this implies then that the f of x1, well, f of x1 will be x1 squared, so it's x1 squared plus 1 must be equal to f of x2, yeah, which is x2 squared plus 1, okay? Well, what does this imply? This implies that x1 squared must be equal to x2 squared, okay? Now, if we get the square root of both sides, okay, well then this implies, yeah, that x1 must be equal to plus or minus the square root of x2 squared, which implies that x1 must be equal to plus or minus x2. Okay? So really what we're saying here is this, is that there's two possible x values that will give us equality here, yeah? Okay? There's the situation, okay? There's two situations here. Let's consider x1 equals plus or minus x2. There's situation 1, there's case 1, okay? There's case 1 where x1 is equal to plus x2, yeah? Which is basically x1 is equal to x2, okay? So what we have here in this particular case, if x1 was equal to the positive x2, if they were the same, okay, well then that's okay. The function would be injective. But there's an alternative. There's case 2. There's case 2 here. It's where x1 is equal to minus x2, okay? Well, if x1 is equal to minus x2, yeah, well then that implies, okay, that x1 is not equal to x2, okay, because it's equal to its negative, yeah. Okay? So under the assumption where we said we take two values from our domain, okay, take two values for our domain. Okay. We assume that they've been mapped to the same place. So we assume that they've been mapped to the same place. Okay. The consequences of that is that we have two possible scenarios. We have the first scenario, okay, where the two values are actually the same. They came from the same spot. And then we have the alternative scenario where the two values are actually different. One is the negative of the other, okay? And we can't have this. We can't have two different values being mapped to the same spot. And this is a consequence of this particular derivation here, okay? The consequences of us assuming that the two values are the same, the consequence is that we end up with the possibility that the two values were the negative of each other. That makes sense. That one was equal to the negative of the other. In other words, the two values were different. Okay, that's a consequence of this assumption here of us letting f of x1 equal f of x2, which implies this implies that hence f is not injective. Okay. F is not an injective function. So here's one of our examples of a function that's non-injective. Okay guys, once again this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video dealing with injective functions, and in particular this case was where we observed where we had a non-injective function, I hope that this was some way intuitive, and more importantly I hope that was helpful for you, and thanks for watching.